Welcome to the module on handling errors and exceptions in Python. This module describes the various types of exceptions that may occur in a Python program. It provides a descent mechanism to handle the various types of exceptions in the programming language. The module concludes by discussing how to raise an exception deliberately, followed by the mechanism to define and use user-defined exceptions. After going through this module, you will be able to discuss errors and its types in Python, explain types of exceptions in Python, explain exception handling techniques, and explain user-defined exceptions in Python. In any language, a program may not always produce an expected output, or it may produce no output at all. This situation arises because of errors in a program. Anything that breaks the normal flow or execution of a program may be called an error. Sometimes a program produces an error during execution and sometimes before execution. Errors in Python are mainly categorized into two types: syntax errors and exceptions. Syntax errors are also called parsing errors. These errors arise when the parser is unable to parse a statement in a program. A statement that is valid for the compiler or interpreter is called a token. In other words, a syntax error arises whenever the parser is unable to find a valid token. Look at the program on your screen. The code in this program produces a syntax error. Syntax errors do not let the program execute, only an error message is displayed. When the programmer attempts to run the program, no output is produced on the Python shell. Instead, a pop-up appears that contains the error message generated by the interpreter. A parser parses all the tokens in a program before letting the shell execute it. The moment it finds an invalid token, it raises an error straight away and thus, the program cannot be executed. This means that syntax errors cannot be handled by a Python program. Exception are another type of errors in Python. Unlike syntax errors, exceptions occur during the execution of the program. In other words, when the parser can parse all the tokens, but is unable to perform the desired action, an exception is raised. Exceptions can be handled by a Python program, since they do not stop the program from being executed. Look at the program which illustrates what an exception is. The code in this program successfully executes until the user enters a string instead of an integer value, resulting in an exception. The program then terminates abnormally without executing any further statements. In Python, there are various types of exceptions for specific errors, all of which are directly or indirectly subclasses of the base class, base exception. Only the class exception inherits base exception directly. The table on the screen lists some common exceptions in Python. In Python, exceptions are handled by using the try-except block. Look at the syntax. The suspicious code is placed inside the try block, where the exception is caught, and the except block is responsible for handling the caught exception. The keywords try and except are used to catch exceptions. When an error occurs within the try block, Python looks for a matching except block to handle it. If there is one, execution jumps there. Let us look at a simple program that implements try-except blocks. In the program, the exception is easily handled in the except block, where exception handling code is written. In this case, the exception handling code consists of a single message that tells the user to enter a correct input, an integer. You can handle exceptions by using try-except blocks. But sometimes you need to use multiple except blocks to handle exceptions. To understand this, let us imagine the example of the previous program. That is, what if the user enters 0 as the input? 0 is an integer, thus, a user can give 0 as input. This will result in an arithmetic error since division by 0 is not possible. The solution to this problem is to use multiple except blocks that handle different exceptions. Thus, multiple blocks are used where the suspicious code can throw multiple exceptions. This program illustrates the use of multiple except blocks. The same goal can be achieved by using an empty except statement. Here, the program is executed twice to test both the exception handler codes. In the first attempt, a string is given as input that raises value error exception caught by the first except statement. In the second attempt, 0 is given as the input that raises an arithmetic error exception caught by the second except statement. The try-except block can also have an else clause, which is used to execute the code that is not suspicious. In other words, if no exception is raised in the try block, the code in the else block will be executed. The code in this program illustrates the use of else clause. The problem with some exceptions is that the program is not executed completely, even after writing an efficient exception handling code in the except clause. This can be very dangerous in certain situations. Such problems can be solved by using the finally clause. The code placed inside a finally block is always executed, irrespective of whether an exception has occurred in a program. The code in this program illustrates the use of the finally clause. An exception can also have arguments that provide additional details about the exception. This program illustrates this concept. Check the output of this program. The exception handler produces additional information about the exception caught in the try block. Exceptions in Python can also be deliberately raised by the programmer. This is useful in situations where the programmer wants the user to enter specific values for a given input type. This program illustrates how to raise an exception in Python. A Python programmer can create his or her own exception classes that handle exceptions specific to a program. These user-defined exception classes must be derived from the base class, exception. These exceptions are like any other user-defined class in Python. They can have any number of attributes and methods, but are usually kept simple, with enough attributes and methods to convey the information about the exception. This program illustrates the concept of user-defined exceptions. The summary of the module on handling errors and exceptions in Python is shown on the screen. I will pause for a few seconds to allow you to read it. In the next module, you will learn how to handle concurrency using threads in Python. Thanks for watching the video. Let us move ahead with next video.